Okay, so what we're going to look at here for just a little bit of time is we're going to look at finding the nth root of a sub n, or a to the n power. So this would be a problem that might look like, x plus 3 squared, and you want to find the square root of it, or x minus 1 cubed, and you want to find the cubed root of it. So these are our examples, kind of what we're talking about. So there's two basic rules. There are two options that you can worry about, that we kind of follow. So the first one is if n is an even positive integer, so like the ones that we care about would be 2, 4, 6, etc., even positive integer, then the nth root of a to the n is going to be written as the absolute value of a. Okay, the absolute value, remember, because we care, we can't have a negative value come out of a square root. We can't have a negative value come out of a fourth root. So whatever we have coming out of that even root has to be positive. So to prove that it's positive, we write it as the absolute value of a. On the other hand, if n is an odd positive integer, and that's pretty much starting with 3. We have 1, but it's kind of a silly case. So 3, 5, 7, 9, 2, 2, 2, 2, 2, like that. Then the nth root of a to the n is just a. So really the biggest thing to remember is if you're square rooting something or fourth rooting something, that your answer has to be positive. So we force in those absolute value signs to make it be positive. But if you're third rooting or fifth rooting, we don't care if it's positive or negative. Either one is fine, so we just leave it as a by itself. So we'll work a couple of examples right quick. So if you had a problem like, it said, what is the square root of negative 3 squared? Well, you could work it out by hand, and you could say, well, I'm looking at negative 3 squared is 9, so square root of 9 is 3. Or we can use our formula. So we have negative 3 squared. We can write in our absolute value signs and put in a negative 3. So put in that a, that's our base. So putting in negative 3, absolute value of negative 3 is just 3. So we get the same answer. And that's just to prove to you that we do. It's not always going to be that straightforward. So let's take a look at another one. So if we had the square root of x plus 5 squared, what we'd want to write is, now we can't work that one out like we could with those just numbers. So what we're going to do is write absolute value, and then right here what was on the inside of there, which would be x plus 5. So that's going to be your answer, because we don't know whether that value really is going to be positive or negative, because, say x was, negative 10. Then inside there we'd have negative 10 plus 5, which would be negative 5. But we can't have the square root of something being negative, so we really do need to have those absolute value signs to make it positive. Okay, so if you had a problem like the third root of 2x minus 7 cubed, something like that, all you need to do now, we don't have to worry about absolute value signs because it's an odd root, and since it's an odd root, I could have a plus root or I could have a minus root. It's really no big deal. So now all I have to do is just take what this was right here, it's 2x minus 7, and just write it. So the cubed root of 2x minus 7 cubed is just going to be 2x minus 7. Alternatively, if we'd had, say, 2x minus 7 to the fourth, we're taking the fourth root of that. Now, since this here is an even number, I've got to go throw in my absolute value signs again. And now I can plug in just that internal bit of mess there. And that's just about as weird as it gets. I guess the last kind of thing they might make you do is they might make you work for it a little bit. Say you had the square root of x squared plus 2x plus 1. If they made you work for it, they could make you actually factor this or unfoil it. So if we wanted to factor that out, we could say, okay, well, I have an x. This is positive and this is positive, so these are both positive. And that's 1, so this must be 1 and 1. And I can check, make sure I get the right answer. My first, outer, inner, last. So I got first is x squared, outer plus x, inner plus x, last plus 1, x squared plus 2x plus 1, so that works. So I have, if I look at this though, x plus 1 times x plus 1 is the same thing as x plus 1 squared. So I can replace this here with x plus 1 quantity squared. So the square root of x plus 1 quantity squared is going to be equal to something with an absolute value sign. And that something is what's on the inside of that function right there. So you're all set.